In this tutorial, we will create this trailing effect in Blender using geometry nodes. But before that, spare me a few seconds to introduce you to our latest procedural tool, Trail FX. Here I am in the latest Blender 4.0, but you can use Blender 3.6 as well for this project. I have this animation of this knight from 𝒚𝒐𝒎𝒆 and this sword from Sketchpad. I also have this object called reference. It is a simple mesh with no faces, which tells our effect about the blade shape and its movement. Since we are going to start from scratch, I delete this now and show you how you can create this reference object easily. This sword is parented to the right hand bone of this knight's rig using a child of constraint. That's why it moves with the hand. To see the bones, I select the armature and enable in front option from here and go to pose mode. And here you can see this is the bone we have parented the sword. I'll hide the armature. To create the blade reference, I select the sword and go to edit mode. Select the vertices of this edge of the sword. Then hit Shift D to duplicate it and hit P to separate the selection into a new object. And thanks to the child of constraint, it also moves with the animation. But if you are making your blade reference separately, then add the child of constraint from here and select the armature first. Then select the bone and hit set inverse. Like that. So, we have our reference mesh. I rename it to trail reference. Now let's create the actual trailing effect. I add a mesh plane to the scene and call it trail blade. Go to the Geometry Nodes workspace. Create a new Geometry Node setup and I call it Trail Blade as well. Pin it. We don't need the initial geometry, so I delete the group input. I drag and drop our trail reference object into the setup. Set it to relative. I want all these mesh vertices as points, so I plug a mesh to points node here. You can increase or decrease this radius to see the points clearly. I also changed the shading color to random as well. Now to create the trailing effect from these points, I want to spawn them to the scene every single frame. For that, I add a simulation zone into the setup. Now to add these points every frame, I add a join geometry node here and plug our points into it. Now if I delete this viewer node and play the animation, you see it's add these points to the scene every frame where our blade was at that frame. These are the points we're going to use to create the trailing effect. But before that, I want to delete these points after some time. For that, we need the particle's edge. So let's calculate that. I add a store attribute node and change the data type to integer, since we are calculating the edge by frames. I call this edge. Then I add a named attribute node to access that attribute. Paste that name and change this to integer as well. And for every frame, I add 1 to the age. So particles start their age at 0 when they spawn, and every frame that age will increase by 1. Now we can delete those points after some time. For that, I add delete geometry node here. Duplicate our attribute and check whether it is greater than or equal to, let's say, 20 frames. Plug that into selection. This way, every particle which has an age of 20 or above will get deleted. Let's reduce this to 10. You can see it is working nicely. Now to convert these points to a trail mesh, it is important that the index of these blade points go from 0 to its max amount from either top to bottom or from bottom to top. I add an index node. We have 15 points and their index goes from 0 to 14. Now I drag from here and add compare greater than node. Actually, I changed this to equal. Now you can see when I cycle between these index values, they are not in any order. We can't have that. We want them to go from one end to the other. In some cases, this setup will work without any more work, but when you are making a template, you have to make sure it is working for every other situation as well. So, to get the index going from one end to the other, first I remove this node and add mesh to curve node. Follow it up with a curve to points node. Change the mode to evaluated. Now if I do the same check as before, you can see we are getting the index number going from one end to the other. Let's organize these nodes. Now let's see how we can turn these points into trail mesh. I add a grid mesh primitive. Now what I'm trying to do is attach these vertices of the grid to each point of the simulation. Points on the blade for Y vertices and points created over time for X vertices. For that, first we need to grab the position data of these points. Add a sample index node. Since we are grabbing the position, I set the data type to vector and plug a position node into the value. Index node to here. This way we can grab the position data of the points through their index. This is also why we needed them to be in order previously. Now to use this data to displace the grid mesh, I add set position node and plug the captured value into position. Now if I plug this into output and increase our grid vertices amount, we kinda getting a mesh trail effect. But it has a few issues. The reason for that is, right now we have a fixed amount of vertices in our grid mesh, but our trail simulation is constantly spawning and deleting points. So we need to make sure the vertices amount of the grid mesh matches the simulating points amount at every time. First, let's find out how many points we have on the blade reference. For that, I drag from here and add attribute statistic node. Plug index as the attribute and this 𝒚𝒐𝒎𝒆 gives us the highest index number. But since the index starts from 0, I add 1 to it to find the points count. Let's use that as our y-axis vertices amount. Now to find how many points we have along the trail path, first I calculate all the points in the simulation. Just like before, add a statistic node. Find the maximum index value and add 1 to it. Since we already know how many points we have along the blade, let's take this value and divide it by that number to find how many points we have this way and plug that into X vertices amount. Now when I play, you can see it dynamically updating and giving us a perfect mesh trailing effect. You can add a subdivision surface node to smooth this trail. Change this to keep corners to adjust the corners. And that is our trail mesh effect. Let's organize this a bit. To create our material, we can use this UV map from the grid mesh. So I add a store attribute node and store these UVs as blade UVs. Then I add a set material node here to assign a material. But first we need to create one. By the way, the reason why you see in this icon is right now our trail does not have any faces to add this material. But as soon as the animation plays, you can see the icon is gone. So let's create a material and I call it trail blade 1. Assign it to the trail from here. Let's go to the shading workspace and start creating the material. For this tutorial, I create a simple material. So first thing first, let's import our UV data of the trail. For that, I add an attribute node and type our UV attribute name. It should work, but I think I might have misspelled it. Let's go back to the geometry setup and copy the attribute name and paste it here. And it is working. So make sure to always spell this correctly. We don't need the principal BSDF node for this. I drag from this vector and add a separate XYZ node. Let's use this. I plug a color ramp into the X output. Change this to B-spline for smoother results and adjust the sliders. Then I plug this to a factor of color mix node. I change these colors to something like this. I add an emission shader. Plug this to its color and increase its strength. Also, I add a transparent node and mix these using a mix shader. Plug this into mix factor as well. To make transparency work in Eevee, I change this to alpha blend in material settings. You can see it is working in both cycles and Eevee. Also, I duplicate this mix node like this and put it here. Add a color ramp to this and increase the contrast. I just want to add a small hot area near the blade. Plug it into the second color input. Change the blend type to color dodge. Change this factor amount to adjust its influence. And that is our trailing effect. You can start and stop this simulation by adding a switch node to here. Plug our points into the true socket. Now you can animate this checkbox to feed the points to the simulation. Like this. And that's how you can create a mesh trailing effect in Blender using geometry nodes. So don't forget to check out Trail FX. And if you'd like to see how you can improve this setup into a template with a few more features, an extended tutorial on that is available for Patreon members. So until next time,